Welcome to myprojectbazaar.com. Now we can going to discuss about the project grid connected PV wind battery based multi input transformer coupled bidirectional DC to DC converter for household application. Now we can going to discuss about the abstract of our project. In this proposed system designed to main strategy of power flow management of entire grid system and our battery, solar and wind turbine of different renewable resource we have hybridly integrated with balance our entire system in which efficient multiple input transformer coupled bidirectional DC to DC converter is present. This proposed system aims to satisfy the load demand and manage the power supply of the entire distribution system and supplies to the our grid connection inputs. So our batteries reserve system has an charging and discharging state will occur that. So in case some demand response our load much improve our battery storage system for charging and discharging performance. So we can analysis also required. The transformer coupled boost half bridge converter is harmless powerful wind, while we can bidirectional buck boost converter also very effective in manner for PV solar panels and different renewable resource energies of the systems. Next we can going to discuss about the flow dynamic way of project. First we can see about the solar panels. The number of solar panels are connected in subsystems, a large number of subsystems. We can using the 72 number of cells when connected in solar panels. This is an passing into the another maximum power point tracking and DC to DC boost converter also this supplied in this particular block. So this is an main one of the renewable source of solar panel. This is interface to multi-input transformers coupled and bidirectional DC to DC converter. Another thing we can see about the wind turbine. The wind turbine is an driven the wind speed to using the for our renewable resource energies of wind turbines. So we can using the model of DFIG block we can using the wind turbine. So similar to we can input of the or multi-input transformer coupled bidirectional DC to DC converter. And again one about we can see for the battery storage system. The battery storage system is on bidirectional using for two arrows because of this one bidirectionally. So using the for charging and discharging characteristics. So sub much we can AC load we can consume the more power. It's support to the battery. If enough is it is enough to solar and wind, it must be disconnected and is charging the battery. So this is an mainly act as a multi-input transformer coupled bidirectional DC to DC converter. It is main block of this our entire process. So this is an switching pulse is a very important one of the methods. Some mathematical derivation to solve this input pulses will given that. Another thing we can pass into the inverters. We our converter output is purely DC, so it is passed to the inverter, bidirectional inverter. So the bidirectional inverter utilizes some AC load and excess of energy stored as grid. So similar that this is an bidirectionally inwards to the grid and outwards to the grid. So bidirectional switching pulses also given the efficient manner. This is a large combination of hybrid resource of renewable resource. So the system has a very balanced and sufficient to store the energy and sufficient to demand response of the our entire load system and some energies are stored also gridding. So lot of losses are minimized this process and the system has a very balanced. Next we can going to discuss about the running procedure of our project. The proposed system implementation done in MATLAB version 2013A. First open the MATLAB window and create a new model file and the creating elements as per the circuit diagram of the base paper and the corresponding scopes are connected in the our corresponding results placed in our short circuit voltage and short circuit current. So this is our entire processing over modeling. Next we can going to see the our modeling result. This is our entire modeling for solar panel, battery, wind turbine, and a grid. So a lot of different results we can connecting. This is our scopes also, entire scopes, and this is also our very important to us. This is our switching pulse results. This is an main of the our entire process. Because of we are using the input decoupled transformer for bidirectional DC to DC converter. This is on switching pulse, some mathematical derivations to solve these particular sections of switching pulses will given us switches. First we can see about the solar panel of PV characteristics. This is our PV characteristics of solar panel for 230 volt, nearly getting amplitude level of the solar panel. This y axis is on power, x axis on voltage. So this is on PV characteristics curve. Next we can see the IV characteristics. This is on our IV characteristics curve. Y axis is for current and x axis on voltage. So this is an IV characteristics curve. Next we can see the every scope results. This is a grid voltage. It's a perfectly sinusoidal wave. Grid stored energies. 300 amplitude levels will achieve that. So it's get maximum voltage. Next this is a grid current. Grid currents are some distortions, but we can voltage regulation is a better much more. So not deviating the current is a very little power of the current. This is a combination of grid connected voltage. This is a current and voltage of grid connected. Use the y-axis zoom, x-axis zooming. This is for our triggering pulse of DC to DC boost converter and saturation region for solar panel. So this is one our DC to DC switching pulse and the solar panel. And this is our PV for VDC. This is an VDC for solar panel for boost converter. Another thing is on solar current and solar voltage. This is an wind turbine. Not this. Use this amplitude level to this maximum level. So we can get the results of current and voltage. This is not for noise. This is on our various period applied in wind turbine. So different results we can getting the each timing periods. So different. This is on our switching pulse of inverter for grid and load. Use the x-axis zoom and click on the track. This and we have 4 switches. First switch is off and the second switch is randomly on. So this is an opposite of every switches. We can on and off, on and off. So this is a continuous system as an balance to entire load and the grid connected. These is our switching pulses for bidirectional buck boost converter. First switch and T1 switch is on totally on, and T2 switch is totally off. This is on switching pulses for transformer coupled boost dual half bridge converter. So this is on a small duty cycle ratio will achieve that this pulse for T3 and T4 switches. This is our switching pulses for half bridge dual converter. Similar that this is for another switch, another 2 switches for T5 and T6. These are randomly on and off triggering pulses. This is an battery result. So battery results and achieve that voltage on 38.85 maximum power latent and this battery is support it discharges, and so current will goes to 0. And let us see these cells are bidirectional DC to DC converter result of switching pulse.